175 Newton force directed along line AB. So it's a force exerted, right, like that. And it's 175 newtons. Scale of magnitude, right, along that line. And it says we want to replace that force with equivalent force couple system at E, or at C on this hinge. Okay, so we're looking for F, right, and M at C. The equivalent force is just the rectangular components of this force that we will move here, and its associated couple by moving it here, which we could find by doing R cross F. Very good, R cross F, right? Where a moment at C is equal to R, the position vector, B with respect to C, right? Where the force is being applied to the point of rotation at that hinge. And the cross product of its force vector along this line, which R cross F, I'm going to call TAB, right? TAB. Great. So, step one, we will use the unit vector concept to reduce that force along AB into its rectangular components. So the first thing we need to do is determine what vector AB is. Vector AB, you get from here to here, right? We gotta go 100 millimeters positive I minus 67. 33 millimeters positive I. So it's 33 millimeters I hat. 990 positive J hat. And we're going back into the plane, right? Negative 594 K hat. I don't even bother convert these to meters at this point because I know when I'm done, the units are all going to drop out, right? With the unit vector. The scalar magnitude or the physical distance along line AB is found by the square root of the sum of the squares, right? Of I, J, and K, and it should result in an answer of 1155 millimeters. And to determine the rectangular components of AB, or TAB, is going to be equal to the scalar magnitude of TAB and the product of its unit vector along that line. They gave us the scalar magnitude, that was at 175 Newton force, right? And its unit vector is 33I 990J, 33I plus 990J minus 594 K hat, all over the scalar magnitude of AB, right? This by that times that, this, and this, and you're going to get the rectangular components of TAB is going to be equal to 5 newtons, 5.00 newtons I hat, plus 150 newtons J hat, and then it's minus 90 newtons K hat. And this is the resultant or the equivalent force, right? That's it. In its confidential form. Now that we have that, the only thing else we need is that's going to go in the second row, right? Of our determinant. And we need the position vector. B with respect to C, right? Or B with respect to C is equal to get from here to here, right? It's positive 750 minus 67. So that's what, 683? Positive, at this point, 0.683. I'm going to convert this to meters now because, right, we're going to put that in the determinant of Newton meters. Okay, so we went from here to here. Right, now I want to go 1850 minus 990 is 950. No, right? That's
it's 860.
Yes, 860. And it's minus, right? 0.860. brings us from there to here, and there is no K, right? So that's right. So that's the position vector. Now we can put it into our moment equation and resolve it. Moment at C is equal to R B with respect to C cross T A B, right? I J K and that's I hat and this is J hat. 0.683. 0.8 negative, 0.860, 0, and the rectangular components of the force is 5.00, 150, and 90. We don't know how to resolve the determinant, right? So I'm just going to go right to the answer. And after you resolve this, in terms of the moment, component moments, you should get 77.4 Newton meters. I had 61.5 Newton meters. J hat and plus, right? 106.8 Newton meters. J hat. And that's the equivalent couple acting on the hinge. Let's see. Right? Everybody good with that? Anybody have any questions at all? Good, then they're done. Everybody wants to take a picture or whatever, now's the time.